Question 14. Each day that Barney goes to college, he either goes by bus or he walks. Depending on whether or not he walks or whether or not he takes the bus, he has different probabilities in which he's going to be late. So the probability that Barney will go to uni by bus is 0.3, and the probability that he walks is then what's left over from that. So I can immediately write in 0.7 because both probabilities of this branch must, or these branches must add up to 1. If he goes to college by bus, so in other words, we're looking at this situation being here, the probability that he'll be late is 0.2. So that 0.2 refers to this here. So we can write 0.2 in there, which, given there's only one other option here, he won't be late 0.8 of the time. If I look at the other route, if he happens to walk to college, the probability of him being late is 0.1, which means this value here is 0.1, and the complement of that not being late will then be 0.9. That is the completed probability tree diagram. Barney will go to college on 200 days next year. Work out an estimate for the number of days Barney will be late to college. So there's two ways that he can be late. The first way he can be late is if he goes by bus and is then late. So we've got to try and find the probability of him taking the bus first of all and then being late. And then the other way that he could be late is if he walks first before being late. So we'll have the probability of W and L, which means that we're really looking for the probability at this part here and this part here. And because of the fact that either of those would be acceptable ways of being late overall, we add them together. So the first part, we're going to have 0.3 times 0.2 to give us the probability of him taking the bus and being late. And then the probability of him walking and being late will be 0.7 times 0.1, giving us the two numbers, 0.06 and 0.07, or you could technically just type that in your calculator in one go and get the probability of him being late as 0.13. We're not done yet though, because we are told to figure out an estimate for the number of days he actually is late. We've just figured out the probability on any given day. So in order to actually answer the number of days we expect him to be late, we've got to take that 0.13 and times it by 200. Times it by 200, which will give us 26 days as being our estimate. Done.